Hi friends, welcome to SSC Electrical. In this video, I am going to discuss about important multiple choice questions for electrical exams. See here, up to this I have discussed 1 to 45 questions from the topic of DC generators, and in this video I am going to discuss 46 to 50 questions. So along these videos I will give the PDF for 1 to 50 questions also. Which of the following components of DC generator plays a vital role for providing direct current of DC generator? Which of the following component of DC generator plays vital role for providing direct current of DC generator? The correct answer is, you can see, dummy coils, commutator, eye bolt, equalizer rings. We know that dummy coils we use for mechanical balance and equalizer we use for reducing the unequal distribution of current, and eye bolt is like a hook, it doesn't make a important role here. And commutator converts AC to DC, generally it converts AC to DC, and it plays a vital role for providing a direct current in DC generator. So the correct answer is B, commutator. So practically you can see here how commutator appears to be, and this is the commutator, this converts AC to DC. Okay. The main function of this commutator is collection of current from the armature conductors. Collection of current from the armature conductors, and actually induced current in armature conductors is AC, and that will be converted into DC in case of DC generator. Here each commutator segment is separated by thin layer, that is the insulation, that is made up of mica. Here insulation also usually asked in question, means so what kind of insulation is used here? That is a mica insulation used between these commutator segments. So these will be connected to copper lugs. So therefore we can say that commutator provides DC current in DC generator. Second question, in DC generator the ripples in the direct EMF generated are reduced by. So you can see the options: using conductors of annealed copper, using commutator with a large number of segments, using carbon brushes of superior quality, using equalizer rings. The correct answer is using carbon brushes of superior quality. If we use superior quality of carbon brushes, we can reduce the ripples in direct induced EMF. So practically carbon brushes will be appears to be like this. These are the carbon brushes. If we use a superior quality of carbon brushes, we can reduce the ripples in the EMF. Okay, if we use the superior quality of carbon brushes, we can reduce the ripples in the EMF. Next question you can see, in DC generators lap winding is used for. In DC generators lap winding is used for high voltage high current, low voltage high current, high voltage low current, low voltage low current. If you know the answer, just answer in comments. In DC generators lap winding is used for. So lap winding having more number of parallel paths, you can see here. So here in case of lap winding, number of parallel paths equals to number of poles. So in case of this is lap winding, in case of wave winding, number of parallel paths equals to 2. So here more number of parallel paths, so more current will be generated. So high current, for high current applications we use this. So this is high current. So option will be in A and B. So we know that EMF generated formula for DC generator E equal to, we can write it as pi Zn by 60 into P by A. So from this formula we can say, for example we have taken a poles of 6 poles we have taken, for example 6 poles we consider. So if the poles are 6, in case of lap winding, then what happens? Number of parallel paths becomes 6, and in case of wave winding, number of parallel paths becomes fixed radius value, that is a 2. So in case of lap winding 6, in case of wave winding 2. So what you can say, in case of lap winding, so number of parallel paths is 6, the number of poles is 6 given, so 6, and number of parallel paths is, that is poles are 6. So what you will get, number of parallel paths A equal to 6. So 6 cancel, so E equal to pi Zn by 60 you will get. So in case of wave winding, what happens? For the same fraction, what happens? E equal to, so this will be same here. So remaining portion is P by A, means that is P by A. Number of poles is 6 and number of parallel paths is 2. So you will get the fraction as 3. It is multiplication of 3 in case of wave winding. So here the voltage is less in case of lap winding, voltage is more in wave winding. So high current and low voltage applications. So simply what we can say, in DC generators, lap winding, more number of parallel paths. So in lap winding, more number of parallel paths, so more current will be there. So high current, low voltage applications, we use lap winding. And what we can say, high voltage, low current applications, high voltage, low current application we use for wave winding. Again I am repeating, for lap winding, high current, low voltage applications. In case of wave winding, low current and high voltage applications. So next question, based on same concept, this question is there. So two generators A and B have a 6 pole each, and generator A has a wave wound armature while generator B has a lap wound armature. Ratio of induced EMF is generated in A and B will be A is to B ratio is asking. So induced EMF in A, that is E and EB, we can say induced EMF in A and B ratio is asking. So we know that formula as pi Zn by 60 into P by A. What we can write? So pi Zn by 60 into P by A is to pi Zn by 60 into P by A. So ratio of this. So in case of first one, what is asking, wave wound given. So only two factors majorly change. So number of parallel paths. So in case of wave wound, then what happens? What is the number of parallel paths given? 6 given. So if number of parallel paths is number of poles 6 given. So we know that in lap winding, number of parallel paths equal to number of poles. So A becomes 6. Again I am repeating, number of poles given are 6. So P, in place of P I have written 6. And in case of lap winding, number of ratio asked for wave wound and lap winding. In case of wave wound, number of parallel paths is, number of poles is 6 and number of parallel paths is 2. In case of wave winding, it is 2. Okay, so ratio we are calculating here. So in case of lap winding, number of poles is 6 and number of parallel paths is 6, because in lap winding number of parallel paths is 6. So what you are getting, in case of wave winding, in place of P6 A 2, in place of P6 A 6 you are getting. So 2 3s are, so 3 into remaining portion you are getting. In this case what you are getting, 1 into remaining portion you are getting. So what you are getting, the ratio is, so this portion will be cancelled and total 3:1 you are getting. Okay, so the correct answer is 3:1. Again I am repeating, so induced EMF formula is equal to pi Zn by 60 into P by A. And in case of wave wound and lap wound, major difference is number of parallel paths. Here the P by A is the ratio and here the P by A is the ratio. In case of wave wound, what happens, number of poles is 6, number of parallel paths is 2. So 6, 2 you are getting, 2 3s are, so 3 you are getting here. And in case of lap winding, number of parallel paths 6, number of poles given is 6. So 3:1 you are getting, remaining portion will be cancelled. Okay, so 3:1 is the correct answer here. It is the last question. The voltage drop for which following types of brush can be expected to be least. The voltage drop for which following types of brush can be expected to be least. Voltage drop is least in which one? Graphite brushes, carbon brushes, metal graphite brushes, none of this. If you know the answer, just answer in comments. So here the correct answer is metal graphite brushes. So in case of metal graphite brushes, what happens? Specific resistance or resistivity is less. Here the rho is less. If rho is less, then what happens? R equal to rho L by A. As the specific resistance is less, then what happens? Resistance will be less. Therefore, V equal to IR. So voltage drop also will be less. You can see here metal graphite brushes. This is the metal graphite brush. You can see here, this is the metal graphite brush. For this you can see what is the specific resistance. Specific resistance, you can see what is the specific resistance, 3 to 15. 3 to 15 specific resistance, that is a ohm meter, 3 to 15 ohm meter. So as the specific resistance is less, what we can say, as the rho value is less and the resistance R equal to rho L by A. So as the rho value is less, total resistance will be less. Therefore V equal to IR. So R also will be less. Therefore voltage drop will be less when we use the metal graphite brushes. So voltage drop is less for metal graphite brushes. So we can say the voltage drop is less for metal graphite brushes. So these are the 5 important multiple choice questions, and 46 to 50 questions we have discussed. Along with this, I will give you the PDF of 1 to 50 questions, and in description you can check it, and regularly you can watch these videos, and total 1000 multiple choice questions will be covered in this. So thanks for watching this video. Please like this video and share this video with your friends, and don't forget to subscribe this channel for more videos. Thank you.